yes or no.
For what?
Did Josh say something or not say something?
He's
All
no.
the pages.
Okay.
So that's like a no.
Okay, functions and graphs. Domains are the inputs. Range are the outputs. A function from a set D to a set R is a rule that assigns a unique element in R to each element in D. The natural domain is the domain assumed to be largest set of X values for which the formula gives real Y values. A boundary is made up of endpoints also known as boundary points. The interior are the remaining points. Or interior points. A closed interval contains boundary points but an open interval does not contain boundary points. Now we're going to look at even and odd functions. And also talk about symmetry within that. So a function y equals f of x is an even function of x if f of negative x is equal to f of x, or an odd function of x if f of negative x is equal to negative f of x. So if plugging in a negative makes the whole thing positive, it's even. If plugging in a negative makes the whole thing negative, or I should say opposite, then it's odd. That's for every x in the function's domain. So then in regards to symmetry, the graph of an even function is symmetric about the y-axis and the graph of an odd function is symmetric about the origin. Next, we're going to look at functions defined in pieces. So this is something like y equals f of x is equal to, what's that, curvy bracket, negative x when x is less than 0, x squared for 0 less than or equal to x less than or equal to 1, and 1 for x being greater than 1. So what this means is that when x is less than 0, so that means anything over here, our function is negative x. That means it has a slope of negative 1, y-intercept of 0. So I'm just going to look. Something like that. Then it's x squared for 0 less than or equal to x less than or equal to 1. So that basically means I have a little piece of a parabola. And then it's 1 for x greater than 1. So at that point, then it just becomes a straight line. Yeah, so this is a piecewise function, so each piece gets graphed individually. These tell you where it's occurring, like when this is what the graph looks like. So for anything x less than 0, so that means anything on this side, we have basically the function y equals negative x plus 0 is basically what we're graphing. So it has the intercept at 0 and it's a negative slope, so it goes this way. Then from 0 to 1, it's x squared, so it's basically like a little piece of a parabola. But it stops at 1 because then anything x greater than 1, it's just equal to 1, so it's just a straight line across.
Okay. Do you have to close the bracket?
No. So then absolute value functions. Y equals the absolute value of x is defined piecewise by the absolute value of x is equal to curvy bracket negative x for x less than 0 and x for x greater than or equal to 0. So technically, absolute value functions are piecewise functions. And so it's going to look something like that. It's your absolute value function. So for x less than 0, it's negative x, so it's kind of the same thing that was up here. And then for x greater than or equal to 0, then x is just a positive slope there. So absolute values always have two answers. One of them is always positive and one is always negative, so that's where they're getting the v part from. Then the domain for this is either all real numbers, or we can write it as negative infinity to infinity because it covers all x values. For range, it goes from 0 all the way up, so it's going to be close bracket at 0 to infinity.
Is that your symbol for all real numbers?
This one? Yeah. Then the last thing is a composite function, which is a function composed of another. So f of g of x or f of g of x is the other way we can write it. Those are the two ways you'll pretty much see it written. I don't remember off the top of my head what this book does when it writes them. I think they typically use this notation over here. That's my preferred notation, but